So we've already covered congruent triangles. These are triangles having the same size, same shape as the triangles are showing here. And if I slide one, place it over the other, you can see they both have the same size, they both have the same shape, and it means all the corresponding angles inside each triangle are congruent, and the corresponding sides of each triangle are congruent. What are the three congruency theorems?
The three congruency theorems are side, 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 angle, side, angle, and of course side, angle, side.
Right, so now after dealing with congruency, we want to move on to another concept that we have to study in geometry, is the concept of similar triangles. This is when triangles have the same shape, but not necessarily the same size. And I'd like to draw your attention to triangle DEF. If I slide DEF over these two triangles, you can see that the three triangles here are congruent. However, if I take DEF and slide it over triangle ABC, you can see that they're not congruent. However, you can see that angle D is congruent to angle A.
We also see that if we slide DEF down, angle E is congruent to angle B. Similarly, if we slide it to the right, angle F is congruent to angle C.
So this means when you have similar triangles, all three corresponding angles are congruent. Angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. There's another interesting characteristic of similar triangles, in that if I take DEF and I slide it so that DE aligns with side AB, and I'm going to take a triangle congruent to DE and slide it along AB, you can see here that it takes two sides of DE to complete one side of AB. This means that AB divided by DE gives you a ratio. We call that ratio the ratio of similarity. And because it takes two, we can say the ratio of similarity in this case for AB to DE equals 2.
If we continue with this idea and shift DEF down, we notice that for the bottom side, BC, the same thing occurs. So now K is equal to BC over EF. Our ratio is going to be, again, equal to 2. Furthermore, if we shift this last remaining triangle over to the right and on top, we notice that for the side AC, DF is again half of its distance. Therefore, AC is twice DF. So our last remaining ratio K is going to be AC divided by DF, which is equal again to 2. Ergo, we notice that all three ratios are the same.
So this is an important characteristic of similar triangles. And when you identify that triangles are similar, one of the things that is useful to use is a statement of similarity. So the statement of similarity is that ABC, triangle ABC, is similar to, and this is the symbol for similarity, is similar to DEF. However, when you make this statement, you have to be careful on how you arrange your letters for each triangle, because the corresponding vertices must take the same order for each triangle. For this reason, if I start the first triangle with letter A, second triangle must start with letter D, because A corresponds to D.
If we continue that, if we start with B, then we must continue with E. So here, after A, we placed B. Therefore, our next line has to be E.
And the final letter, the only one left, letter C corresponds to letter F. So when you complete the name for the triangle ABC, you must complete the name for the other triangle, DEF.